Okay, this is the first part of IR spectroscopy notes. Okay, so general introduction on the IR. IR is an analytical technique. Analytical technique that helps determine the structure. Because let's say you have a sample in a vial, you don't know what is the sample. So you send the sample for the IR spectroscopy, and then it helps you to determine the structure. But solely depends on IR, it cannot give you a complete answer what is the structure, because for the structure determination you need all these four tools, which is the IR. What IR spectroscopy do? Measure the bond vibration. So the words here is bond vibration. I will explain later what is the vibration frequencies of a molecule. And then you need to have the NMR spectroscopy. Okay, what NMR spectroscopy do? Detect signal from hydrogen atom and carbon. Okay, so we also need the UV spectroscopy, and last one is the mass spectrometry. So with all these four type of spectroscopy, only then we can conclude what is that molecule. Okay, solely from the IR, you only know what are the functional group present in the molecule. Okay, so since IR is one of the topic in SSCK 1623, so what are the principle? What are the principle of IR? IR used to determine the functional group. The keyword here is the functional group and the class of organic compounds. That's why for our first class last week, I asked you to draw the structure of benzaldehyde. So the class is aldehyde, and the functional groups mean what are the bonds present in the molecule, what are the bonds present in benzaldehyde. And then from there, you can determine the structural formula if you are given the molecular formula of the molecule. Let's say without the molecular formula, only the IR spectrum, you cannot identify what is the structure of the molecule, but you can list or you can identify the functional group that present in the molecule. So all this is the principle of IR in terms of the physical aspect. So you don't need to understand that in depth. Okay, so what you need to understand is the principle of IR is on the vibration. What is it mean by vibration? Let's say in this case you have these two balls. So these two balls represent the atom. Let's say you have the C bonded to the H. Okay, what happens if you stretch these two atoms and then you release? There must be a vibration. And then again, if these two atoms you compress and then you release, there also a vibration that happen in these two atoms. Okay, so the covalent bonds in molecule are constantly vibrating. These two bonds, they are vibrate. The vibration, there are two types of vibration. One is stretching vibration, another one is bending vibration. In stretching vibration, there are symmetry and asymmetry. As you can see here, symmetry means at the same side or at the same arrow. If asymmetry means one is up outside, one is inside. That is the asymmetry stretching. But as I mentioned earlier, you need to only focus on the stretching vibration, because these two atoms, they are vibrate. Okay, two types of vibration is stretching. In stretching, they have the symmetrical stretching and they have asymmetrical stretching. Besides that, they also shows the bending vibration. There are four types of bending vibration: scissoring, as you can see here, wagging, rocking, and twisting. But for bending vibration, this is not important, because if we list everything, all the stretching and bending vibration, you cannot see what is the significant value for that compound. That's why we only focus on the stretching vibration, whether it's symmetry or asymmetry. Okay. Okay, the next thing is this is all regarding the theoretical of the IR. When you look at the correlation chart, you see different frequency and wave number. So what influence the frequency or wave number for bonds is depending on the bond strength. Okay, bond strength here is referring to the single bond, double bond and triple bond. Okay, just think for a while, when you have a double bond compared to single bond, which one will vibrate stronger? Okay, when you have single bond and then another compound, these two atoms is bonded by the double bond. So bond strength will influence the frequency of the bonds. And then another one is atomic mass. Okay, what does it mean by atomic mass? When you compare OH bond and CH bond. So here just now you compare single bond, C double bond O and C single bond O. When we compare, we need to compare in terms of the bond strength and atomic mass. Okay, so this is the one that I mentioned just now. So for the different type of bonding, double bond, single bond and triple bond, as you can see, when you have a triple bond, the frequency is higher. Okay, when you have C connected to another C with triple bond, when you stretch and you compress these two atoms, what happened to the vibration? Is it's vibrate faster or it's vibrate slower? Okay, compared to another factor, when you have the atomic mass, when you compare CH and CC, okay, CH, the frequency is 3000. When you compare CC, the frequency is 1200. Okay, when you have a small molecule, small atom, C and H, okay, imagine when you stretch and you compress, what happened to the vibration of the molecule? Is it faster or slower? So the answer is it's vibrate faster. So that's why the frequency of the molecule is higher. So this one you don't need to memorize, because you have the list from the correlation chart. You just can refer to the correlation chart frequency. Okay, next, the thing that you need to understand on the IR active, what does it mean by IR active and IR inactive? Even though when you look at a molecule, okay, there are so many types of bonds present in the molecule, but not all bonds are IR active. IR active means there are a dipole changes, a dipole moment that changes between the molecule that can absorb the infrared light. Whereas for IR inactive, there is no changes in the dipole moment. So what does it mean by this? Okay, let's say when you have C triple bond C connected to H, and you have another molecule C triple bond C, one is connected to CH3, another one is connected to H. So first thing, when you look at the molecule, you need to list all the bonds present. So in this case, you see C triple bond C, okay, and you see the CH sp. Whereas for this one, you see C triple bond C, oops, wait, you see C triple bond C, you see CHSP, and you see CHSP3. Okay, so now compare the C triple bond C here and C triple bond C here. So why I said the C triple bond C is IR inactive, whereas for this C triple bond C is IR active. You need to look at the whole structure. Okay, this carbon bonded to H, this carbon bonded to H. If there is any dipole moment, both sides are same. So the dipole moment is equal to 0. Look at the second structure. This carbon bonded to H, this carbon bonded to a methyl group. So is the dipole moment is 0? No. There are dipole moment here. That's why the C triple bond C here is IR active. So when the bonds are IR active, means it absorbs the infrared light and you can see a peak in the spectrum. So this is meant by IR active and IR inactive. Okay, the intensity of absorption. What does it mean by intensity? When you look at the peak, you see very small peak, very moderate peak, and very strong peak. Okay, so this is weak, this is medium, and this is strong. So why some peak are weak, some peak are medium, and some peak are strong are depending on the change in dipole moment. If the change of dipole moment is big or greater, so the intensity of the peak or the intensity of the absorption is higher. So in this case, when we compare the OH and CH, you have OH is very electronegative, O, compared to C. Okay, so of course the OH is more polar, so more intense means the dipole moment, the change of dipole moment between these two atoms is higher. That's why when you look at the spectrum of OH, the intensity of the peak is strong compared to when you look at the CH. Okay, so this is the factor that influence the intensity. Intensity means whether the peak is weak, medium, or strong. The second factor is the number of bonds responsible. So when we compare octyl iodide and methyl iodide, there are about 17 CH in octyl iodide, whereas for methyl iodide is only 3 CH. So the number of CH present in the molecule responsible for the intensity of the peak in the IR spectrum. The last one is on the concentration of the sample. If your sample is very concentrated, you will see the peak, the intensity of the peak is very high comparing to the diluted sample. Okay, the rest is only on the technique on how you run the IR. Okay, the most important part is to interpret the IR spectrum. That's I will explain on our second part of IR notes.
انضم معنا الآن واشترك بالقناة ليصلك كل جديد. YSAG، معا نحو مستقبل مشرق.